So sometimes we need to graph inequalities that have two variables in them, an x and a y. The inequalities we've done so far have all been only in one variable, so they may have had y is greater than or greater than or equal to -1, or x is less than 2, or x is in between -3 and 2, those sorts of things, only one variable at a time. So now we're extending a little bit further, and we're looking at inequalities that have two variables. So something like y is greater than or equal to -x plus 1. What does that look like? So the good news for you is that you're going to be able to use the calculator for all of this in future, and you don't need to know how to do this by hand, but you do need to know how to use your calculator in order to help you to get that onto a piece of paper. Okay, so things you need to take note of when you put this into the calculator. You need to take note of things like, is it a solid line or a dotted line? Can I figure out what the x-intercept is? Can I figure out what the y-intercept is? Can I figure out which part of the graph I'm supposed to be shading, which bit is the required region, and label accordingly? Okay, so if we go to the calculator, remembering that the calculator shades the required region, and we look at something like y is greater than or equal to -x plus 1. In the past, you would have done things like graph an equation of y equals -x plus 1. And you could have figured out all sorts of things like y-intercept, gradient, x-intercept, all that business. But now we're doing one slight extension onto that skill, okay, and that's shading the region. So once we know the line, we basically are going to either be shading above or below that line. Okay, and our calculator will tell us which bit we're going to be shading. So for something like this one, y is greater than or equal to -x plus 1. So when we backspace that function notation off, y is greater than or equal to -x plus 1. And there we have our shaded region above the line. We can see clearly that's a solid line. And the two other bits of information I need to be able to graph this accurately is what are those two key points? What's the x-intercept? What's the y-intercept? Okay, so again, menu 6.1 will give me x-intercept. Okay, so the point 10 is the x-intercept, and menu 5.1 will give me the y-intercept. When I hit enter, that gives me the y-intercept, I think the quickest way probably. So I do have now two accurate points, 0, 1 and 1, 0. I know it's a solid line, and I know the above the line part is the shaded required region. So when you go to hand me this as your answer for that question, you would also remember to have to shade the key and say the shaded bit of this graph is the required region. Okay, somebody else may, when they're sketching, sketch the same line, and they might shade underneath the graph like this, and then tell me that the white bit is the required region. That would also be correct. Okay, both of those answers there tell me that the bit above the line is the required region. So depending on which part you shade, it's really important that you tell me which part is the required region, because both of those answers look completely opposite, but they're both correct. Okay, so keep that in mind. As if you're shading the required region, tell me that the shaded bit is the required region. If you're leaving the required region white, tell me that the white bit's the required region. Because without the key, both of the answers are going to be wrong. You don't get marks if you don't actually tell me which bit's which. Okay, so when you're doing these questions, I think the first one's quite easy. Even the second one is quite easy. The only thing you'll have to remember when you do the second one is that your line will be a dotted line. Okay, so when you do that one and you put it into your calculator, y greater than -2x plus 4, you'll need to remember it's a dotted line. you'll have to figure out what's the y-intercept, what's the x-intercept, and which part do I shade, and then which part is the required region. Okay, so all of these questions are going to have either dotted or solid lines. They're all going to have x and y intercepts labelled, and they're all going to have required region highlighted. Okay, so in something like that one, y greater than negative 2x plus 4, and you put that into your calculator, go on a new page so you've got a nice clean graph. Delete y greater than negative 2x plus 4. So you can see clearly dotted line, and also the region above the line is the required region. So whether you leave it white above and highlight white region is required, or whether you shade it and indicate shaded region is required region, that's important. And you then would need to highlight the x and y intercept. So menu 6.1 gives me x-intercept, and menu 5.1 gives me y-intercept. So pretty quick and easy to do it on the calculator, and then your task is to be able to transfer it from your calculator accurately onto the paper. Okay, so then we move on, because we're not going to let you off that easily. We move on and say, okay, let's do 2 at once or 3 at once. And quite often in year 11 and 12, we get 4 at once or 5 at once. Even in year 12, we often have 5 regions shaded on the one graph. Okay, so it does become quite crowded on there. I might let you have a go at that first one, example 1 on your own, and I'll go through this one, example 2, and then I might do one more from the next page. So with this particular one, when you've got 2 regions overlapping, it's not so bad to see which bit is the required region. So it's the bit that's got 2 layers of shading on it. So if you did, a green section and a pink section or something, it's the bit that overlaps and has pink and green together. So 2 lots of shading is probably about as many as you want to be able to figure out which bit's the required region. Okay, so if you're looking at something like this one, y is greater than or equal to x plus 1, and then x plus y less than or equal to 3. So let's have a look what that looks like on a graph to start with. So on a clean graph page, let's go to a new one. And I want to type in y greater than or equal to. So delete y greater than or equal to x plus 1. And then to get another graph on the same set of axes, tab, and I want to type in x plus y is less than or equal to 3. So you can see it starts to get messy pretty quickly. I'm getting my labels out of the way for a minute. So the section that I'm interested in is the section that has both grey and pink. So it's this funny 1, 2, 3, 4, 5 pentagon, this pinky grey coloured thing on the left. That's the required region. So to get that accurately onto my graph, I'm going to need quite a bit of investigating here, because I need intersection points and I need intersects and I need all kinds of accurate labels on here. So basically what you need to be doing is analysing this graph, so x-intercepts, y-intercepts, and you know how to do that. But one thing I don't know that you've been shown, at least for a little while anyway, is intersection points of 2 lines. So if you go into your menu, and menu number 8, 1, 4. Okay, menu 8, 1, 4. Lets your calculator, you can see up here, my calculator's in the intersection point mode, and it tells me to get the intersection or to calculate that intersection point, click on the first graph and then click on the second graph. So what intersection point do I want? This one. And I get that by the intersection of the black graph and the pink graph. Okay, so when I click the black one, click, and click the pink one, click, it highlights for me what the intersection point is. So menu 814 gives me that intersection point. And the menu 61 and the menu 51 will get you x-intercepts and y-intercepts on there also. And then you'll be able to accurately put that two sets of straight lines onto your graph with paper and then sketch over here this coloured in part, this left-hand side bit that's got two lots of shading on there. That's the bit you would put into your paper and shade that as your required region. All right, so I don't want to do every single question here because I want to leave you some stuff to do yourself. So I'm just kind of starting you on some of these. When you flip over, you'll see that sometimes there's more. There's 3 at once or 4 at once or something like that. And what happens is that, as we've seen, even with 2, it starts to get a bit messy. So basically what we do, once we start getting too much mess and we can't decide how many's got, you know, which part's got 3 bits, which bit got 2 bits, or which bit's got 5 bits shaded or whatever, sometimes it's easier to tell the calculator to shade everything you don't want and leave everything that you do want white. Okay, so the calculator just by default shades the required region, no question. So we want to tell the calculator with something like this where I've got 3 regions to overlap, I want to tell the calculator to shade the opposite, to shade everything that I don't want. Okay, and then what happens then is that it leaves my required region white, which is much, much, much easier to see. Okay, so the skill of being able to shade both the required region and the not required region is important. So if you've got only 1 region, you don't have to worry. You just say, yes, shade the required region. If you've got 5, you might decide I'm going to leave it clean, the bit that I want, and shade off everything else. So rather than telling the calculator to shade x is greater than or equal to 0, tell the calculator to shade x is less than or equal to 0. Rather than telling the calculator y is greater than or equal to 0, tell the calculator less than or equal to 0. And rather than saying x plus y less than or equal to 8, tell it x plus y greater than or equal to 8. So what you're telling your calculator is to shade the not required region. Okay, and that will mean that your calculator leaves your required region white, and it will be far, far, far easier to see. Okay, so if we were putting this one with the 3 onto our calculator, and we type in x is less than or equal to 0, let's go on a new page, and we'll go x is less than or equal to 0, because I'm doing the opposite. And my tab, my second one was y is also less than or equal to 0. So y is less than or equal to 0. And then my third graph, so let's tab again, was x plus y. I can't remember what way the sign went. Let me have another look. Greater than or equal to 8. So what my calculator's done, I'll just make this a bit bigger so I can see the whole thing. What my calculator has done now is shaded out all the bits that I don't want. And it's left for me the bit that I do want, white. Okay, so much, much easier to see here that the required region is white than to decide, is it this part here that's got 2, or is it possibly this part here that's got 3, or is it this part over here that's got 3? It's too hard to tell. It's much, much easier to see the white bit than it is to see the part that's got 2 parts of shading or 3 parts of shading or whatever. It's too hard. So sometimes it's much easier to say leave the bit that I want white. And then if I do my menu 814 again, my intersection one, menu 814, then it's just a matter of going click the green one and the brown one, and then click the orange one and the brown one, and then click the orange one and the green one. And I've gone bang, 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 3 corner points. Really easy to put that on my graph now. I know the y-intercept is 0, 8. I know 0, 0 is another corner point, and I know the x-intercept 8, 0. They're the 3 corner points of the required region. And then I know that little right angled triangle is the section that I want, rather than all that other coloured stuff, which is the bit that I don't. Okay, so it's very, very easy then to put that onto your calculator, sort of backwards, and then on your graph, let me get some straight line work here. So what I've got is 5, 6, 7, 8, and 5, 6, 7, 8. And then this section here is a part of the required region, and then this bottom section here is the other bit of the required region. And then you could label in using your pen. 8, 0 is an important point, 0, 8 is another important point, and 0, 0 is another important point. And whether you shade all the outside and leave the triangle white, or whether you shade the inside and leave all the rest white, doesn't matter. As long as you label the little key and say the required region is that triangular shaped bit, you're good to go. Okay, so I want you guys to try this next one. This has got 4 on the one graph. And again, I want you just to practice going opposite. So instead of typing in x is greater than or equal to 0, I want you to type in x is less than or equal to 0, y greater than or equal to 0, so you're going to go the other way, x plus 2y, opposite, and 6x plus 4y, opposite. So by doing these opposites here that are highlighted on the right hand side there, it basically makes your calculator colour in everything except what you want, and then in the end the mess is all going to be outside the region, and the region that you want is going to be really obviously white and clean. Okay, so I'm going to leave you with example 4 to do on your own and see whether you can get, number 1, all 4 of those inequations onto the graphs page on the one graph, and then using that menu 814 to see if you can highlight accurately the corner points of the required region.